Okay, so we're going to cover section 5.8 today. And the next three sections are all going to be about solving triangles. So there are two types of triangles that we're going to be looking at. One, today we're going to be focusing on right triangles. And then if a triangle does not have an oblique angle, it's called an oblique triangle. I'm sorry, if it does not have a right angle, it's called an oblique triangle. So when you solve any triangle, you have 6 pieces of information. And what it means to solve the triangle is to find all 6 pieces of information, the 3 sides and the measurement of the angles. And in order to do that, you have to have at least 3 known quantities. And if you have, doesn't matter if it's sides or angles or combination, if you have 3 known quantities of the 6, you can find the other 3. And that's how we solve triangles. So like I said, today we're just going to focus on right triangles, which we've kind of done this already. So this is sort of a review. In this example, I'm given that B equals 21 and the side is always represented with a lowercase letter, and it matches the letter for the angle. So here we have capital B is the measurement of this angle, and opposite of that angle is lowercase b. Capital A is this angle, and opposite that is lowercase a. And then we have our right angle here, and C is the hypotenuse. The hypotenuse is always opposite your right angle in a right triangle. So that's our situation. We already know, it looks like we only have 2 pieces of information, but we actually have 3 because we know this is a right triangle. So C is 90 degrees. And as long as you know 2 angles, you can very easily find the 3rd angle by subtracting the sum of your 2 angles. So if we add these together, we have 129.2 degrees. And if we take that and subtract it from 180, we will get the 3rd angle. So this angle here, B, is 50.8 degrees. Okay, so that's our first piece of information. Now we need to find the other 2 sides. We know B equals 21. So let's go ahead and find A. And we know the angle A here is 39.2. I'm just going to draw that in here. And that's given to us, B is given to us as 21. And A over B is going to be tangent of 39.2. So 21, I'm sorry, A over 21 equals tangent of 39.2 degrees. And now we can solve this. We just multiply both sides by 21. And we get A equals 21 times tangent of 39.2. And when you're doing this calculation, make sure your calculator is in degrees. Oops, I did it wrong. Hold on. And we get 17.1. I think for these problems, they want you to round your angles to whole numbers. So I probably would go ahead and round this as 51 degrees, and that's how I would enter it. Whoops, sorry. I would go ahead and round it as up to 51 degrees. And here I'm going to round to the tenths place. So I'm going to round it to 17.1. Now, finally, we need to find the hypotenuse, and we can use the Pythagorean theorem since we know A and B, or we can use the fact that the adjacent over the hypotenuse is cosine. Either one works. I'll go ahead and use the Pythagorean theorem. So when you C squared equals A squared plus B squared, but then you're going to take the square root of both sides. So C is the square root of A squared, which we found to be 17.1, plus B squared, which was given to us as 21. So 21 squared. And let's just double check and see make sure my answer was correct. So I'm going to take the square root of 17.1 squared plus 21 squared, and that's 27.1. So now we found the other three pieces of information. We were given these three, and so now we know that B equals 51 degrees. Little a is 17.1, and little c is 27.1. So we have solved the right triangle. Any questions on? Yes. Right. I picked tangent because I want to know the opposite. I know the adjacent and I know the angle. So tangent of the opposite over the adjacent, or tangent of 39.2 is equal to the opposite over the adjacent. That gave me this equation right here. And I only have one unknown, so I can solve it. If, let's say I'd been given the hypotenuse instead. Let's say someone told me the hypotenuse was 27, then I would have used sine because I'd be looking for the opposite, but I knew the hypotenuse, so I would say opposite over hypotenuse is equal to sine of 39.2. So whatever information you're looking for, you want to combine that with what you know, and then apply the right trig function, whichever one works. Well, I need at least three pieces of information. So it depends on what you're given. So like if you're given two angles, then you want to start and just add the two angles, together and subtract from 180. So I was given that this is a right triangle. So I knew that C was 90. I was also given A. So I start here. And then whatever you use, I could have found the hypotenuse first and did something like tangent of 58.8, just whatever you've got and whatever you're looking for. You want one variable or one unknown to be in the equation, and the rest of the equation, you want to have your known values plugged in so you can solve it. But you have a lot of tools at your disposal, so there's more than one way to do the problem. Like here at this point, I could have used cosine is 21 over C. Cosine of 39.2 is 21 over C. I could have done it that way. Or here I use the Pythagorean theorem. There are multiple ways to solve these. So there isn't necessarily a right way. I will have you on the test, solving a triangle like this and a few others. So you're going to have to show your work. Because there's so many steps involved, you want to show your work. Because if I can see that you understand the process, if you make a small mistake, I can give you most of the credit. Whereas with multiple choice, it's a little bit harder to do that. So I've been working on the test just since I brought that subject up. 100 points out of 150. So in other words, 2/3 of the test is multiple choice and 1/3 is where you work out the problem and show your work. And I will I'm in the process of creating a review assignment for you to help you study for the test. And that is October 4th. So it's a couple weeks away. Then the last day to drop without academic penalty is October 6th. So by October 6th, you will have all the information you need as far as your grade goes. So anyway, let's do some more examples. So this time, I don't know, I know that it's a right triangle. So I'm going to draw that, but I'm given two sides. So B, so this is A, B, C. A equals 12 and B equals 22.6. So again, to solve these, you just need 3 pieces out of 6. In this case, I know that it's a right triangle, so I know my C equals 90 degrees. And then I know the two legs, two sides of the triangle that are the legs. I know those. And I want to find the hypotenuse, and I also want to find angle A and angle B. Okay. So I'm going to start off with using the Pythagorean theorem. Since I have my two sides, I can find the hypotenuse. And using the Pythagorean theorem gives me the square root. C is the square root of 12 squared plus 22.6 squared. And if you use your calculator, $25.6. Okay, so one thing about triangles, the smallest angle is opposite the smallest side, and the largest angle is opposite the largest side. So I kind of know what's going to happen here. Of course, in a right triangle, the hypotenuse is always the largest side. And that makes sense because 90 degrees is obviously going to be your largest angle, because in a right triangle, the other two angles are always acute because they add up to 90 degrees. So they can't be more than 90 degrees. So it makes sense that the hypotenuse is going to be the largest side. And then I know that because this side here, B, is larger than side A, or longer, I should say, I know that the angle opposite of B, in other words, capital B, is going to be larger than this angle A. Okay, so that's just a little piece of information to help me at the end of the problem. I might want to look at my answers and make sure they make sense, just to see if I've done it correctly. So I'm going to use the fact, and now because I know all 3 sides, I can use any trig function that I want to find the other sides. So let's just try for angle A, let's try cosine. Okay, so I don't know this angle here. Well, we'll call it angle A. I don't need theta if I already know A. So I'm going to go cosine of A is equal to the opposite or adjacent over hypotenuse. Here's my adjacent, 22.6. And I found my hypotenuse was 25.6. So I have this, I take what I know, plug it into my equation. The cosine of my angle A is 22.6 over 25.6. Now, in order to solve this, I have to get the A out. So I'm going to use cosine inverse. Okay, so I'm going to leave myself some room. I'm going to have to apply cosine inverse to both sides. So on the left, I take cosine inverse, and on the right, I take cosine inverse. And since I've done it to both sides, I've preserved the equality. Well, here, cosine inverse of cosine of your angle A is going to be just plain old A. And then I'm going to use the calculator. Make sure my calculator is in degrees. That's your first step. Always make sure you're in the right mode. And then I'm going to take cosine inverse of 22.6 divided by 25.6. And I know I'm going to get an acute angle because the bottom number has always got to be bigger than the top number. If it's not, you've done something incorrectly. But there's my angle, 28 degrees. Okay, so I've got now the last step is to find the angle B. And now I can just take 180 degrees minus the sum of these two angles, 90 and 28. So the sum of 90 and 28 is going to be 118. And so if I subtract that from 180, I'm going to get 62. So there I've completely solved the triangle. These are the three given, and now I have that A equals 28 degrees, B equals 62 degrees, and finally, lowercase c we found to be 25.6. So like I said, you're always given three pieces of information to find the other three. And it doesn't matter, you know, what combination it is, if it's two sides and an angle or two angles, etc. You can figure out the rest. All right, any questions on this one? So let's do some application problems. One of the application problems from your homework, by the way, this homework is pretty small, easy homework, which is nice to have every now and then. Let me just show you. So there are only 6 problems. Here, that again, they just give you, you know that the angle is 90 degrees, and you know that you've got A, capital A, 32.5. I think this is the one I did actually. For example, 1. And then this might even be the one I did. Well, no, this is a little different. Here's another right triangle. This time they give you 2 sides. In this particular problem, you have two right triangles. You have to solve them separately in order to get the length of the base here. So you have the adjacent and you have an angle, and all you have to do is find the opposite. So you're not going to have to solve the whole triangle. You just need to solve this, get this opposite. So you're going to use tangent, and you might label this right here as x1, and then this distance down here as x2. So to find x1, you take x1 divided by 460, that's opposite over adjacent, and set that equal to the tangent of 49 degrees. And then to find x2, you're going to take x2 divided by 460 and set that equal to tangent. And then you'll get x1 and x2, add them together to get this distance here. Okay, that's how you do that problem. This one, notice you don't know the angle here, and you can't really do anything because it's not a right triangle. So what you're going to do is you're going to find the outermost right triangle. You're going to solve that for this distance from this point to here. That's opposite of the angle 29 degrees. So again, you're going to take opposite over adjacent. The adjacent is 580, and then take tangent of that. And then you're going to do the same for the 24 degrees. You're going to take this distance divided by 580, set it equal to tangent of 24. And then you're going to take the difference. You're going to take this longer length, subtract off this shorter length, and that will give you this length, the x. So all of these problems are pretty much the same thing. Let's do this one. I'll set this one up for you. We can even do it. It's a pretty easy problem. The tallest television transmitting tower in the world is in North Dakota. From a point on level ground, 5,280 feet, which is 1 mile from the base of the tower, the angle of elevation is 29.3 degrees. Approximate the height of the tower to the nearest foot. So the best thing is to draw yourself a picture. So here's our tower, let's say. And here's the ground. They gave us that this angle was 29.3 degrees and that this distance is 1 mile or 5,280 feet. What number is this? I forget. This is number 5. Okay, so we want to know this height. That is what we're looking for. So the opposite over the adjacent is tangent of your 29.3 degrees. And again, the reason why I picked tangent is because of what I need to know, which is the opposite, and what I know, which is the adjacent. Tangent relates the opposite over the adjacent. So that's why we have this ratio here. And now I'm going to go ahead and multiply both sides by 5,280 feet. And on the left-hand side, those are going to cancel. And then I'll go ahead and calculate this in my calculator. And we get, well, if you round it, 2,963 feet. I'll set up the last problem for you on the homework. Any questions on this one? Okay, so the last problem, I guess they give you a picture, I don't really need to set it up for you. But one thing you should know for this problem, just to kind of refresh your memory on trig. Let's see, we are supposed to find the distance D at the bottom there. And don't forget that you're probably going to use opposite over adjacent again, okay? Because we don't know the hypotenuse. And we need to know the hypotenuse for if we want to use the sine or cosine function. So we're looking for the opposite. We know the adjacent. So just like in the previous problem, you're going to take D divided by 1100, but you're not going to take tangent of 37 because D divided by 1100 is tangent of this angle here, which is the complement to 37. So that angle is 90 minus 37. So here's our triangle. This is what we're looking for. Here's 1100. This is 37, and this is a right angle here. So it's going to be 53, right? Because 37 plus 53 is 90. So when you set it up, it's going to be tangent of 53 is equal to D over 1100. And then you solve for D in that problem. The next section that we're going to cover is 7.1. And we're going to be using in this section the law of sines. So in section 5.8, in the examples we just did, all of those triangles are right triangles. And so we use our trig functions to solve them. But not all triangles are right triangles. So we're going to learn now how to solve what we call oblique triangles. So we're going to use the law of sines to solve oblique triangles. And not all oblique triangles can be solved with the law of sines. Then in section 7.2, we're going to cover the law of cosines. So it depends on what information you're given. And we'll start out with some basic examples and build up to the harder ones. Sometimes when you go to solve a triangle, it actually has two solutions. In other words, there are two possible triangles that satisfy the given conditions. So there are all kinds of different situations to consider. But let's look at an example here. So, but just like with right triangles, you need three pieces of information. So, oh, and you're probably wondering, what is the law of sines? Well, let me just go back to my triangle here. And notice I'm not drawing any right angles. Well, that kind of looks like a right angle, but let's just pretend it's not. And we have our angles A, B, and C. No right angles. And just as we did earlier, the side opposite angle A is going to be little a, the side opposite angle B is little b, and the side opposite C is little c. C is not the hypotenuse here. It looks like I've drawn a right triangle, but I really did not mean to make it look like that. I'll just, there we go. Something like that. Okay, so we have this triangle and we have 6 possible quantities associated with the triangle. And the law of sines says that A over sine of capital A, this ratio is going to be constant. So B over sine B and C over sine C. So when you take the ratio of an angle with the opposite side, that's going to be the same all around the triangle. So if it's capital A and little a, that's equal to sine of capital B over little b. And by the way, I've written it like this, but this is also true. You can write it whichever way suits you. If you want to go sine A over A and sine B over B like this, you get the same result. They're equal. So sometimes I use this, sometimes I use that, depending on my situation. Which quantity I'm solving for. If I'm solving for an angle, I like to write it like this. If I'm solving for a side, I like to write that like this, but it doesn't matter. It'll all come out in the wash. So let's do an example. Let's see, anybody still writing? Okay. So let's suppose our angle is 31 degrees. That's given to us. We don't know angle B, but angle C, let's say, is 74. And we are given that little a equals 9, and we need to look for little b and little c. Okay, so this is the information we're given. And because I know A and C and little a, I'm going to use A over sine of A is equal to C over sine of C. And so when I plug in my 3 quantities that I know, I get 9 over sine of 31 is equal to little c over sine of 74. So now we have one unknown, that would be little c, and everything else is filled in, so we can cross multiply to solve this. So we have c sine of 31 equals 9 sine of 74. Like that. And then to solve for c, we're just going to divide out by sine of 31. Sometimes what I do, I know for whatever reason, I don't know why, but this particular homework set is pretty long. But you're pretty much doing the same thing. So what I would do is I would kind of just write out the variables. So I would write something like c equals little a sine of, let me think, what was that? Sine of c over sine of a. And if you just leave it like that, then you're just plugging in numbers. You don't have to go through this whole process for every single problem, kind of systemize it. Because for whatever reason, the math department included a lot of problems like this, and they're all pretty much the same thing. So it's helpful if you just do that and then just kind of get into like an assembly line, you just plug it in the numbers, get the answer, plug in the numbers, get the answer. Anyway, that's just a little tip. So we've got our little c now. And let's see, what was that quantity? 16.8. Is that what you all got? Does anybody try that one? I think it's 16.8. And then next time we're now going to solve for little b. And we're just going to do the same sort of thing. We're going to take, but we need to know, in order to solve for little b, we need to know this angle first. And we can just find that by taking 180 and subtracting 105, because 31 plus 74 is 105, and we subtract that from 180. So capital B is 180 minus 105 in degrees, and that's going to be 75 degrees. So you can see, like I said, rather than going through this whole process again, I'm just going to plug in the 9, and instead of capital C, I'm doing capital B. So 75 degrees divided by sine of 31. Okay, it just saves me some time. Otherwise, I'd have to go through this whole process again. And when I do that, I get 16.9. And you can see these two answers are very close in the lengths. B and C are very close. That's because the angles that they're opposite are very close. This one's 74 degrees and this one's 75 degrees. So it makes sense that the lengths are going to be really close. And the smaller one is opposite the smaller length. So the smaller angle is going to be opposite the smaller length, like that. So we got our other 3 pieces of information, the angle B, and then the sides for C and B. Those are the other 3. So we've solved the triangle. That's enough for today. I feel like I've covered enough, and I just want to do a quick check with you real quick. I've got a little bit of a cold, so to avoid you having to get too close to me, I'm going to just put my sign-in sheet over here. Just sign your name on the way out. But do this problem. See if you can do this one first. I drew a picture for you. So you have a kite that's flying at a height of 30 feet, and the string attached to the kite is 65 feet. And if you assume that it's in a straight line, they want you to find the angle that the line makes with the ground. So this angle here, notice we're given information about the opposite and the hypotenuse. So which trig function are you going to use? Sine, because sine is opposite over hypotenuse. Okay, so you're going to go sine of theta equals 30 over 65, and then you're going to have to use the inverse function. Okay, give that a shot. When you're done, just sign your name on your way out. Oh, sure. And if you want to compare notes, you know, see if you get the right answer. Yes, exactly. So you're going to take sine of theta equal to opposite over hypotenuse, and then you're going to have to use the inverse function to find theta. Okay, you're going to take sine inverse of both sides, right? If you want to give it a shot, and then if you're not sure, you know, let me, I can look at it for you. I think you should get 27.5. Is that right? Is that what you got? Yeah. Okay, good.
No, like, is that the right equation now?
Yeah.